All right, time for the triple scalar product. And if you notice, there's no work for this. It does come up later in the course, as in, I think in the next unit. So intersection of lines and planes, that's like a double unit, I think. So first of all, this little red box is what the triple scalar product is. So you've got three vectors, three random vectors. And if you cross any two of them and then take that result and dot it with the third one, that is called the triple scalar product. So it's a bit of a definition. Now there are two uses for the triple scalar product. We're going to do one of them today. And the first one is what comes up later, and that is if the triple scalar product equals 0. So if you do all this work and you end up with 0 as an answer, it means that the three vectors that you've got are coplanar, meaning that they are all lying on the same plane, meaning that they would all lie flat on a piece of paper rather than any of them poking out. So that's what coplanar means. We're not going to do that today. We are going to do the magnitude of the triple scalar product equals the volume of a parallelepiped. So I don't know if you can remember back to geometric vectors, we had a parallelepiped. Parallelepiped is a figure. It's a three-dimensional figure. So especially since we've got this right here, as in the cross product, because we've got the cross product, that means it has to be 3 space, because you can't do cross product for 2 space. And so a parallelepiped is a three-dimensional object. It looks like a box. It could be an absolute upright box, so 90-degree corners in every corner. But the alternative is a parallelepiped could be like a shoved-over box. So as long as you've got two opposite faces of your three-dimensional face being parallel to each other and parallelograms, then you're good to go. So I'm not going to try to draw this picture. I'm just telling you that I'm about to do the triple scalar product. So I need some space to be able to see my examples. So here it is. Determine the volume of the parallelepiped defined by the three vectors. So this thing right here is going to go to the next slide. So if you need it, pause it right now and start scribbling. Okay, time's up. And let's attack this question. So it doesn't matter what order you do things in. What matters is that you pull off the triple scalar product. So I'm just going to work alphabetically. So I am going to do U cross V, and then when I get that result, I'm going to dot it with the other one, which is W. So over here in space, I'm going to do my U cross V information. Now once you get really good at this stuff, you don't have to repeat, scribble, scribble. You can shorten this if you like. I find that dangerous. And I'm going to do my scribbling also over here. So negative 18 minus 5, comma, it's a terrible 5, negative 2 minus 24, comma, 20 minus 6. Now don't reduce this. Do not do that. Don't be tempted to take care of that. So I'm going to do negative 23 as my first component, negative 26 as my second component, and 14 for my last component. And now I have to dot it with the vector I chose not to use, which just happens to be the last one here. And this is dot product, and I'm awfully good at dot product. So negative 23 times 10 is negative 230, plus, there's something I can't do in my head, negative 26 times negative 3 is 78, plus 14 times -4, -56. Don't feel like doing that, so subtract 230, add 78 equals -208. So if you are sitting there thinking to yourself, okay, that doesn't make any sense, volume can't be a negative value, that is why it says, where is it? The magnitude of the triple scalar product. So what we do when we get a negative answer is we will throw on the absolute values, and absolute values means once you're done all the math, so it's kind of like having brackets, once you're done all the BEDMAS stuff on the in-between, you get to take whatever this answer is and make it positive. And I don't know what kind of units these are, but I'm going to say units cubed rather than centimeters cubed because I'm not quite sure. All right. Oh my gosh, that is my all-time quickest lesson.